Okay, so today notes 8.2 will be square root functions. So remember yesterday on 8.1 we were talking about quadratic functions. So today we're just going to be focusing on square root functions. So just like yesterday we had a parent function for quadratic, we have a parent function for square root. So the square root parent function is f of x equals square root of x. Okay, so remember when we were going over square roots a long time ago, we discussed imaginary roots, which are when you have a negative under the square root, because you can't take the square root of a negative number. So we're not going to be graphing any imaginary roots or imaginary numbers. We're only going to be graphing the ones that we're able to see on our x and y coordinate. So I'm going to start with the smallest. The smallest number that I can plug in is a 0 because, again, we can't take the square root of -1 and we don't want to worry about imaginary. So the square root of 0 is 0. The next perfect square would be 1. Square root of 1 is 1. And then the next perfect square is 4. Square root of 4 is 2. I'm not going to 2 and 3 because if I took the square root of that, that would be a decimal, and I only want to plot the whole numbers. The next perfect square would be 9. Square root of 9 is 3. So those are the points that we're going to be referring back to when we're looking at square root functions. So let's go ahead and plot those and see what a square root function looks like. So 0, 0, 1, 1, 4, 2, and 9, 3. And then it curves. So it's like half of a sideways parabola. That is a square root function. So from here on out, anytime you see a graph that's half of a sideways parabola, that's a square root function. So this is what it will look like. So let's talk about the domain of a square root function. So which is your x. Notice it's everything greater than 0. Because remember we discussed we can't plug in a negative, because if we plugged in a negative, then it would make a square root of a negative number, and we can't do that. The range, if you look at the y-axis, we're always going to get positive values. If you take the square root of a number, you're not ever going to get a negative. So same thing, y is greater than or equal to 0. Okay, so that's the square root parent function. Make sure you remember at the end of the notes, or now, pause it, go ahead and transfer that to your gold sheet, your parent function sheet. Make sure you fill it in under square root function. All right, the transformations we discussed yesterday will be the same exact thing as any function. So anytime we put a negative in front, no matter what function it is, it's going to reflect it over the x-axis. So this will reflect over x-axis. So my endpoint of my square root function will still be at the origin. The only thing that will change are the y values. Now the y values will become negative. Same thing as yesterday when we had a parabola. The y values became negative. So instead of our points, if you look back up at the top at your parent function chart, instead of it being 1, 1, it's going to be 1, -1. Instead of it being 4, 2, it's going to be 4, -2, and 9, -3. Make sure you draw an arrow at the end because we could keep plotting points towards the right. So that reflects it over the x-axis there. The next one, remember we discussed yesterday, anytime we have on a quadratic, we had parentheses, that was a horizontal shift. Anytime a number is added or subtracted under your square root, like this one here, if it's all under the square root, that will also be a horizontal shift. So if it says x plus a number, we're going to be going to the left, same thing as yesterday with the parentheses, and then x minus something is going to be going to the right. So this one we're going to shift left 5. So my endpoint of my square root function, so if we look back, your 0, 0 point is always the one that you're shifting. So I'm going to shift it left 5. Everything else stays the same. So the same as yesterday, that's my new origin. I'm plotting my points for my parent function up at the top. So that was 1, 1, 4, 2, and 9, 3. Okay, let's take a look at the next one. Hopefully you see a difference between number 3 and number 4. Number 3, we were adding under the square root. Notice this one, we are subtracting outside of the square root. So if it's on the outside of the square root, that's when we have a vertical shift. So this is going to be shifting down 8. So again, you're shifting your 0, 0 point down 8. So plot that point first, and then everything else stays the same. So 1, 1, 4, 2, and 9, 3. All right, just to go over and review all of our transformations, the negative reflects over the x-axis. Inside under the square root, remember, is a horizontal shift, so that's going to the left because it's plus, so left h units. The next one's still under the square root and it's minus, so that's going to the right. And then on the outside of the square root, we're adding, so that's shifting it up, k units. Minus on the outside would be down. Now, we haven't seen one yet today, but we talked about it yesterday, that a is your coefficient in front. Same as yesterday, if a is greater than 1, it's going to be a stretch. And then if a is in between 0 and 1, it's a shrink. So notice all of your transformations stay the same no matter what parent function you're talking about. All right, let's take a look at 11. So we're given a function, we're going to write our transformations down, and then we're going to graph it. So the negative in front will reflect it. And then under your square root, it's x minus, so it's going to be going to the right 3. And then up 4. Same as yesterday, we're always shifting our 0, 0 point first. So I'm going to shift it right 3 and then up 4. Then I'm plotting the points from our parent function. So I'm going to fill those in. Remember, we did a 0, 0, 1, 1, 4, 2, and 9, 3. So we're plotting. Now, we are also, after we shifted, remember our transformation, we're also reflecting, which means we're changing the sign of our y value. So all these will become negative now. So instead of it being 1, 1, it's going to be 1, negative 1, 4, negative 2, and then I'm not able to plot the 9, negative 3 because we can't go to the right 9. So there's our graph. Your domain, look at the x. Look at your x value of your endpoint. That's at 3, and it's everything to the right, so x has to be greater than or equal to 3. The range, look at your y. Your y value of your endpoint is at 4, and everything below it, so y would have to be less than or equal to 4. let's look at the next page. All right, write your transformations down and then we will graph. So we have a 2 in front. So remember, if it's greater, or a is greater than 1, it's a stretch. So stretch by 2. Under your square root is x plus 1, which means it's going to the left 1. And then the minus 3 on the outside, it's going down 3. So again, shift your 0, 0 point, left 1, down 3. Then we're using the parent function values, 0, 0, 1, 1, 4, 2, and 9, 3. Remember, we talked about if we're stretching it, we're multiplying that y value by whatever the stretch is. So instead of it being 1, 1, it's going to be 1, 2, because we're having to stretch it by 2. And then it's going to be 4, 4. And 9, 6. There we go. So domain, look at the x. Look at your endpoint on the x. It's at -1. So x, it's going to the right. X has to be greater than or equal to -1. And then your range, look at your y-axis. The y value of your endpoint is at -3, and it's going up. So y would have to be greater than or equal to -3. Okay, the next section we're going to be given the parent function. So notice once we get to multiple functions that we're talking about, pay close attention to whatever type of function you're starting with. Then we're going to write the equation based off of your transformations given. So it says we're going to shrink by a factor of 0.5 or a half, which is your coefficient, and then shift 3 units up. So again, I told you yesterday, write g of x, write y equals, whatever you want to put, just make sure it's something equals. And then, so our coefficient would be a half or 0.5. And then we have square root, because that's what it told us we were starting with, square root of x. Since we're going up, we do not want that to be on the inside or under your square root. So that should be +3 on the outside of your radical. The next one, we're reflecting over the x-axis, so that puts a negative in front. We're stretching it by a factor of 3, so that's your coefficient. And then we're shifting 1 unit down, so we have square root of x. Down is on the outside, so make sure you put -1 on the outside of your square root. Okay, last one, we have a graph. So look and see what your transformations are from the graph. So we know our endpoint of our square root graph is normally at the origin. So notice it went 1, left 2, and up 2. Also notice that it's going down, so it also reflected. And then you can check your points 1, 1, 4, 2, and notice it's not a stretch or a shrink. So reflection is the negative. We have a square root, so you have to know from a graph that is a square root function, so you have to know what square roots look like. Since we are going to the left under your radical, you need to have x plus 2, and then up 2 would be plus 2 on the outside of the square root. Okay, so now don't forget, if you haven't already, fill in your square root function on your gold parent function chart. Make sure you just fill it in from number 1 on the notes today. Make sure you're using class time to work on the assignment. They're both going to be due on Friday, so we will have a quiz Friday over those two.